This is Precalc 5.4, Day 2. We're going to finish this up today. We got 3 examples to go through. The first one here is going to bring back, actually not this one, sorry, this one, is going to bring back, they're both the same topic, we're only going to do one of these, is bringing back the idea of, it says write an algebraic expression. And the reason why it's having the expression is because it brings back this idea of cosine, and arcsine, and arccosine, and arctangent. So you're going to have to do the inverse stuff. And if you guys remember, inverse trig functions only exist in certain quadrants. Sine exists, or arcsine exists in quadrants 1 and
3, 4.
4. Arccosine exists in 1 and 2. Tangent is 1 and 4. Nothing is in 3 for arc. They're inverses. Now, to do this problem, as you can see, I have to do the arcsine of 2x and the arccosine of x. I am not actually allowed to take that cosine on the outside and distribute it in. That's a no-go. We're not allowed to do this. You can't just move this in and create 2 separate functions. Notice that it's the cosine on the outside of 2 things added. And each one of these is an arc or inverse, which means each one of those actually stands for an angle. Arc or inverse sine, cosine, and tangent give us angles, where we take trig functions of angles to get ratios. So you need to look on the very outside of this and say, hey, I can separate this using the sum of angles of cosine, because each of these represent an angle. So you think about that and you're like, hey, wait a minute, there's a formula for that. Cosine of an angle plus an angle can be split to cosine of the first angle, which is arc sine 2x, cosine of arc cosine of x. Does cosine keep the sign or change the sign? Change. Minus sine of arc sine 2x. Sine of arc cosine x. All I'm doing is using the expansion of a cosine of 2 angles. At this point, this group, which is a cosine of an angle, will lead me to a ratio. Cosine of this angle will lead me to that ratio, and so forth. So eventually we will get a ratio times a ratio minus a ratio times a ratio. The unfortunate part is that arc sine of 2x, I don't know what it is. And so this is where you have to go back to that idea and write or create your triangles in the correct quadrants to finish it. Arc sine exists where again? 1 and 4. We assume 2x is positive because there's no negative attached, right? So I'm going to make my triangle in the first quadrant. Hey, guess what? That's my angle right there. That's theta. I want that. I need to find that, but I really don't care what that is. It's weird, isn't it? Because I'm eventually going to take the cosine of that same exact angle. So I'm just going to use it as a stepping stone. But here's the cool thing. That particular angle has a sine value of 2x. Now 2x could be written as a fraction, can't it? 2x is just really 2x over 1. And so, what is sine again as a ratio? Opposite over hypotenuse. So therefore it's 2x and 1. Can you finish that triangle for me? Using Pythagoras Theorem. I'm going to call the bottom a b. I can't call it x because I got x in the problem. It'd be kind of difficult to make that happen. So that means I should be able to say that b squared plus the quantity 2x squared is equal to 1 squared. Or if I wanted to, b squared plus 4x squared equals 1. And if I wanted to get b by itself, I would subtract 4x squared, and then eventually take the, so it'd be the square root of 1 minus 4x squared. Now that we found b, I'm going to write it down here. Square root of 1 minus 4x squared. Because here's the cool thing. That particular triangle, way down here, is based off of this arc sine 2x. That triangle was based off of that ratio of 2x over 1. It's used two different places. So first set of parentheses, what is the cosine of this particular triangle? Yeah, it's the square root of 1 minus 4x squared over 1, which is just the square root of 1 minus 4x squared. And then I'm going to go over to the second group and say, wait a minute, I want to know the sine of arc sine. So what's the sine of this particular triangle? Opposite. Hypotenuse, 2x. I now need to do the second triangle. So the next part, I need to do this one now, arc cosine x. And arc cosine x is not the same as arc sine 2x, so I got to create a whole nother triangle. It's arc cosine. Arc cosine exists in which two quadrants again? 1 and 2. X we're assuming is, so we'll be in the first quadrant. There's theta, or a different angle, but it's an angle that we're going to use as a stepping stone. Cosine is the ratio of what? Adjacent over hypotenuse. X is really just x over 1, so therefore it becomes x to 1. Yes? Can you find the third side? Now, we've done this, guys, many, many, many times. You know you're going to square all the sides. Can you guys agree with this? So you're going to have 1 squared, you're going to have x squared, but since you're solving for one of the legs, you should know that you are what? Adding or subtracting? You should be subtracting. So therefore, can I automatically say, I know it's going to be a square root, and you know it's going to be the hypotenuse minus the known leg squared. So the hypotenuse squared minus the leg squared. And if you don't recall that, go through all the work like we did on the other triangle, set it up, subtract it, square them, subtract them, square root, solve. At this point, we have this triangle. Can you now go up here and tell me the cosine of that triangle? It just happens to be x. Oh. That's interesting. Now wait a minute. This one was x. This one was 2x because that's what we started with inside, isn't it? But notice that it was the sine of the arc sine. It was the cosine of the arc cosine. When we did these back in the last chapter, it was a kind of a give or take. Sometimes they just undid each other, were good. And other times you had to watch out for which quadrant you're in, how big of an angle was it, what was the sine going to be. So that's why you build your triangles. Always build, build, build. Now you can go here and do this one, which is the sine of the arc cosine. So take the sine of this, opposite, over hypotenuse, which is 1, which is just a square root of 1 minus x squared. I'm almost done. The only thing I would like to do is get rid of all the sets of parentheses if I can. Can I actually combine these things up? None of this actually gets combined. So, what I'm going to do, though, is take that x and move it out front so I don't get it mixed up inside. And the 2x is already out front, which is nice. And there's your answer. I had to form 2 separate triangles to get through this problem, but I also, in the very beginning, had to expand it using the sum of cosines. Right? Sum of the angles inside a cosine. Notice that if I would have just distributed, I would have not had the whole answer. Now, why is this important? We didn't know what x was. But if I told you x was 1/2, could you figure it out now? I think so. Okay. So there's ways to do this. This is a reason, because we didn't know what x was. Now eventually we can. And there are questions. The next one is just to verify. The 2 examples we have now are just going to go pretty quick. You need to verify the cofunction identity using the difference identity. Notice that the left-hand side of each one of these is just a function of 2 angles being subtracted. That means the left-hand side of each one of these expand. It doesn't matter which one I use. If I go to cosecant, we don't have a cosecant formula. So you have to change cosecant to 1 over sine. So just to start this one, you would go 1 over the sine of pi over 2 minus theta. So everything's underneath 1. Hey, let's just keep going with this one. But now we have a sine, right? What's this sine expansion for a difference? Sine of the first angle times cosine of the second angle, yeah? Sign keep or change the sign? Keep. Then what happens? Maybe cosine of the first angle times sine of the second angle. Right? Sine, cosine, cosine, sine? Does everybody agree with this? And at this point, everything is still underneath 1. But watch what happens. Each one of these I am now going to evaluate, if I can. What's sine of pi over 2? Go to your unit circle, 90 degrees, pi over 2. 1. What's cosine of theta? We don't know what it is, so it's just cosine theta. What's cosine of pi over 2? And sine of theta is just sine of theta. 0 times anything. 0, gone. 1 times anything is that thing. So I get 1 over cosine. And 1 over cosine is secant theta, check. You just proved it. Proved / verified. So verify the cosine of 360 minus theta is equal to just cosine theta. Which it almost seems like it's right, because isn't that almost the same thing as, well, it's not adding or subtracting in 360, I guess, so not the same there. Pretty close. But you guys just use the sum or difference. What's the cosine formula again? So cosine 360 cosine theta plus sine 360 sine of theta. Now, you guys hopefully don't even need your unit circle for these, but what's the cosine of 360? So it's 1 times cosine theta plus 0 times sine theta, gone, which equals? Check. You're good to go. Homework is worksheet 5.4, 9 through 12, 15. Have a great day.